Okay, so in this video I'm going to have a look at the cubic formula again, but I'm going to do a particular example, this one here, x cubed minus 15x minus 4. So this is a depressed version of the cubic equation. So we'll assume that you started with a cubic equation with a quadratic term in here, an x squared term, and you went through the procedure that I showed in the previous video to get rid of the quadratic term. And you've ended up with this term here, and this term is in the form x cubed plus px plus q equal to 0. So what we're going to do is put the p and q into our formula here and work our way through it. So let's start that then. So we want to get the cubed root of minus q. So q is minus 4. So we're going to do minus 4 here and then put 2 here. And then we're going to get the square root of q over 2. So it's minus 4 over 2. We're going to square that. And then we're going to take p, which is minus 15, and divide that by 3 and cube it. And then we're going to do exactly the same thing over here. So we've got cube root here, and then we've got minus 4 over 2 plus the square root of minus 4 over 2 squared plus p, which is minus 15 over 3. We're going to cube that. The only difference between these two is this sign here. Okay, so again we have the cube root minus, well, let's do this. It's minus 4, so it's 4 over 2, which is 2. And then we're going to get the square root of minus 4 over 2 is minus 2. Minus 2 squared is 4. And then we're going to add, well, 3 into 15 is 5. So 5 cubed is 125. So it's going to be minus 125 here. Same over here then. So we just take the cubed root of, it's going to be 2 this time, plus the square root of 4 minus 125. Okay, next line then. So we have the cubed root of 2 minus the square root of minus 121 plus the cubed root of 2 plus the square root of minus 121. Okay, so we have these two cubed roots here. That should be cubed here. Cubed root here, so let's work away with these. So we have the cubed root of 2 minus, well, this is minus 121. It's just going to be minus 1 times 121, and the same over here. So you got the cubed root of 2 plus minus 1 times 121. So we have the cubed root of 2 minus, well, the cubed root of minus 1 is I, and the cubed root of 121 is 11, so we end up with 11i here, minus 11i here. And over here we have the cubed root of 2 plus 11i. Okay, so we need to deal with these two complex numbers here. So just to show you our real and imaginary axis here, so we have our real axis here, imaginary axis here. And we'll just sketch these two complex numbers. So we have one here, so this is our 2 plus 11i, and down here then we have 2 minus 11i, they're conjugates of each other. So to work out the argument, we need to work out the argument and the modulus of both. They're both going to have the same modulus, the same or here. So we have a 2 out as far as here, and we have 11 up as far as here. So using Pythagoras' theorem here, 11 squared is 121, 2 squared is 4, so we end up here with the square root of 125. And the same down here, our or here is going to be 125, square root of 125. So now we've just got to work out the angle here, and well, it's going to be the same angle here. This is our argument, so we have the tan inverse. So we're going to end up with the tan inverse of 11 over 2. Which will be our reference angle. So that's what I'm going to use here. So what I'm going to use is de Moivre's theorem just to convert these to polar form. So let's run through that. Now we have to find the cubed root of, let's put it all in a big bracket here. So we've got to find the cubed root of the square root of 125 times the cos of, now to take this one here, this one down here, our angle is negative. It's going to be the cos of minus tan inverse 11 over 2 plus 2n pi. So this is the general polar form. So it's plus I sine minus tan inverse 11 over 2 plus 2n pi. And we've got to get the cubed root of that, so I'm going to raise that to the power of a third. So this is the first, this is this one here, the first cubed root. So we've got to do the same with this one here, but we're going to be dealing with this complex number up here in the first quadrant. So we do exactly the same thing again. This time we won't have the minus in front of the tan inverse 11 over 2. So it's going to be that plus, and then we've got to do the same thing again. So what I might do is just copy this down and just change a few things. Okay, so I've just copied this down here and I've changed this sign here and this sign here to a plus here and a plus here. So we've got to work through both of these. Now with the Moivre's theorem, what we can do is take this 1/3 here, bring it down, get the cubed root of this square root of 125, and then we've got to get 1/3 of the angle here as well. So let's do that. So the cubed root of the square root of 125 is just the square root of 5. So in other words, we have 125, which we're square rooting, and we want to get the cubed root of that. When we bring the 1/3 down, get the cubed root of square root of 125. So we multiply these two powers, so we can just switch these around. So we can get the cubed root of 125 first, which is 5, so we just need to get the square root then of 125. So we just need to get the square root of 5, so I'm just going to write it like this. Okay, so let's do that then. Let's get rid of this. So this becomes the square root of 5. Now we have the cos of 1/3. Well, initially we have minus here, so it's minus 1/3 of tan inverse 11 over 2 plus 2 over 3 n pi. Got to get 1/3 of this as well, plus I sine minus 1/3 tan inverse 11 over 2 plus 2 over 3 n pi. Okay, so let's that's the first one, then that's plus. Now we've got to do this one here, so it's the same kind of thing again. So it's square root of 5 cos 1/3, this time tan inverse 11 over 2 plus 2 over 3 n pi plus I sine 1/3 tan inverse 11 over 2 plus 2 over 3 n pi. Okay, so this is what we're going to be dealing with when we work out our roots. Okay, so let's work these out. So what we need to do is start with n is equal to 0. And what you'll actually find is when you work out this one here, you'll get 2 plus I. When you work out this one here, what you'll get is 2 minus I. So what we've done here is we've worked out our u and v here. So what we've got to do now is, remember there are 9 solutions, so we end up actually with 3 u's and 3 v's, so 9 combinations in total. So what we've got to do is add these and look for we've got to find the other 2 solutions for u and v, and then look for the combinations that will work. So how do we find the other 2 solutions? What we do here is just simply multiply each of these by omega and omega squared. So let's do that. So we're going to take 2 plus I and multiply it by omega first of all. So 2 plus I, and we're going to multiply this by minus a half plus root 3 over 2I. I'm going to do the same over here. To minus I, I'm going to multiply that by minus a half plus root 3 over 2I. So let's work through these. Well, minus a half times 2 is going to be minus 1, so we've got plus root 3I then when we do these two here. Then here we've got minus a half I, and then these two here will be plus root 3 over 2I squared. Minus root 3I plus a half I, we'll have a look at that in a second. Minus 1, we have minus 1 minus root 3 over 2, because of the I squared here, it's going to change the sign. And then out here we have plus root 3 minus a half I. Okay, so this is our second U solution. So this was our first one here. Just mark that. I'll mark these two. And I'm going to mark this one here. So let's do the one on the right here now. So we have 2 minus I times minus a half plus root 3 over 2I. So again, 2 times minus a half minus 1 plus root 3I plus half I minus root 3 over 2I, root 3 over 2I. So when we do that then, let's put, this was going to be squared here because we're multiplying these two. So this here will become a plus, so we have minus 1 plus root 3 over 2, and then we have plus root 3 plus a half I. That's these two here. Okay, so this is our second V, let's say, so I'll just mark this as well. So we have 4 solutions so far. So we have the first U and the second U, the first V and the second V. So now we've got to go again, so we've got to multiply this here and this here by omega squared this time. So let's work on that. So 2 plus I, we have 2 plus I, which we've got to multiply by minus a half minus root 3 over 2I. That's what we're going to do here, and then over here we're going to do the same thing again. 2 minus I this time. We're going to multiply that by minus a half minus root 3 over 2I. So let's work through these. Here we have again minus 1. We have minus root 3I. We have minus a half I. And then we've got minus root 3 over 2I squared. So again, minus 1 plus root 3 over 2. So I've just changed the sign here because of the I squared. And then I've got minus root 3 plus a half I. Okay, so let's just mark that one. And do this one over here now. So over here we have 2 times minus a half, which is minus 1 minus root 3I. So now we have plus a half I, and then minus minus plus root 3 over 2I squared. So that leaves with minus 1 minus root 3 over 2. That's this one here, and then we have minus root 3 minus a half times I, and this is our third solution here for V. Okay, so I've written out our 6 solutions for U and V, or 3 each. So we've got to look at which combinations will work. Well, as I said in the previous video, these two here will work if we add them, and then these two will work, and these two here will work. So let's just add these and get our 3 solutions for our equation. So let's have a look. We have 2 plus I, 2 minus I. So that's just going to, the i's will cancel. We're just going to end up with 2 plus 2, which is 4. So our first solution, 2 minus I plus 2 plus I. So it's just going to be 4. So let's look at this one here then. Let's look at minus 1 plus root 3 over 2 plus, might actually take away those brackets again. I probably don't really need to do them. So let's take root 3I plus a half I. And then I'm going to add this one here. So it's going to be minus 1 plus root 3 over 2 minus root 3i minus a half I. Let's see what we get when we do all of this. So I can see here I've got minus 1 and minus 1, so that's going to be minus 2. We have plus root 3 over 2 plus root 3 over 2. That's just plus root 3. That's these two here. And I've done these two here. So we also have plus root 3i minus root 3i. So that's plus root 3i here minus root 3i here. And we also have plus a half I, and we have minus a half I here, so they're going to cancel as well. So this is our second root here. So I'll just put a box around this, and this was our first one here, which is 4. Okay, so let's find the third root then. So we're going to do these two now here. So let's work through those ones. So we have minus 1 minus root 3 over 2 minus root 3i plus a half I minus 1 plus minus 1 minus root 3 over 2 minus a half I plus root 3i. Okay, so what do we get when we add all these up? Well, certain things will cancel again. We have a minus root 3i, we have a plus root 3i, we have a minus half I plus half I. So what are we left with then? We're left with these two here. Minus 1 is minus 2. And these two here. So minus root 3 over 2 minus root 3 over 2. That's minus 2 root 3 over 2, which is minus root 3. So this is our third root here. So our three roots then, when we added all these combinations of u's and v's up are, so our roots are 4 minus 2 plus root 3 and minus 2 minus root 3. Now we can't check these three roots. Our equation was x cubed minus 15x minus 4 is equal to 0. So our first root was x is equal to 4. So let's just check that out. So that's 4 cubed minus 15 times 4 minus 4 is equal to 0. So 4 cubed, 4 times 4 times 4 is 64. 64, 4 15s, that's just going to be 60. Minus 4 is equal to 0, so this works okay. 64 minus 60 is 4, 4 minus 4 is 0, so 0 is equal to 0, so 4 works. Our second one then was x is equal to minus 2 plus root 3. Let's see if this one works. So we have x cubed, so we have minus 2 plus root 3, we want to cube that. Minus 15 times minus 2 plus root 3 minus 4 equal to 0. Let's work through that. So minus 2 plus root 3 cubed, that's going to be minus 2 cubed. So this is plus 3 times minus 2 squared root 3 plus minus 2 times root 3 squared is 3 times that, and then plus root 3 cubed. That's just expanding using binomial expansion. Over here we've got minus plus 30 minus 15 root 3, and then we have minus 4 out here. That should be equal to 0 hopefully. Minus 2 cubed, that's going to be minus 8. Here we have plus let's see, no, that's going to be, plus, got 2 2's 4, 3 4's 12 root 3. Over here we've got, let's see, we have root 3 squared, which is 3, 3 3's 9, 2 9's 18, so that's going to be minus 18. Out here we have plus 3 root 3 plus 30 minus 15 root 3 minus 4 equal to 0. Okay, so let's see what we end up with here. We've got minus 8, minus 18, plus 30, minus 4. That gives us 0. So this one, this one, this one, and this one gives us 0. Here we've got 12 root 3 plus 3 root 3. That's 15 root 3. 12, 35, 15 root 3, and this one here is minus 15 root 3, so we do actually get 0 is equal to 0, so this one works as well. And we should find the other one works as well, so let's try it anyway. We have x is equal to minus 2 minus root 3, so same thing again. Okay, so we have minus 2 minus root 3, which we got a cube, and then we got minus 15 times minus 2 minus root 3, and then we have minus 4 here, so that should be equal to 0. Let's check that out. So using the binomial expansion here again, we've got minus 2 cubed plus, no, it's actually going to be minus this time, isn't it? So it's going to be minus, let's say 3 times minus 2 squared, and then root 3. It's going to be plus 3 times minus 2, and then it's going to be root 3 squared, and then it's going to be finally minus, and it's going to be root 3 cubed. Out here then we've got plus 30 plus 15 root 3 minus 4. Hopefully that's equal to 0. So let's see what we get. This is going to be minus 8. This is going to be 4 minus 12 root 3. This is going to be root 3 times root 3 is 3. 3 3 is 9. 2 9 is 18. Minus 18. Here we end up with minus 3 root 3 plus 30 plus 15 root 3 minus 4 is equal to 0. Let's see if anything cancels here. So let's see, we have a... Well, we'll do the numbers first and see what we get. We got minus 8, minus 18, plus 30, minus 4, and that all equals 0. So this one, this one, this one, this one gives us minus, gives us 0. And here we have minus 12 root 3, minus 3 root 3, that's minus 15 root 3, plus 15 root 3, so that gives us 0 is equal to 0, so that one works as well. So our 3 roots work in that particular equation. Now obviously if you started with a non-depressed, the happy equation as I called it in the previous video, you would need to adjust those 3 roots to get back to your the original roots of your original equation. That included the quadratic term. Okay, so that's it for this particular video.